What if I told you that somewhere out there in the darkness of space, something the size of a small city is flying through the universe at 1,000 kilometers per second? And instead of destroying everything it touches, it is planting stars behind it like footprints in wet sand. And what if I told you that we never knew this was possible until Hubble accidentally caught it in a single quiet photograph? Before we go deeper into this, if this kind of story makes your brain light up, do me one small favor. Tap that like button, hit subscribe, and send this video to that one friend who always talks about space at midnight. It really does help this channel grow, and I promise the rest of this story is worth it. Now let me take you back. For most of your life, you have been told that space is empty. Just cold, silent nothing between the stars. A little dust here, a stray rock there, but mostly a giant black ocean with tiny sparkles floating in it. And for the most part, that is true. Space is emptier than anything you can imagine on Earth. But every so often, the universe does something so strange, so out of place, that even the people who study it for a living have to sit back and admit they have never seen anything like it before. That is exactly what happened one ordinary afternoon when a group of astronomers were flipping through fresh images from the Hubble Space Telescope. Hubble has been floating above our planet for decades. It has taken millions of pictures. It has shown us baby galaxies, dying stars, gas clouds shaped like cathedrals, and black holes tearing apart everything nearby. So when a new batch of images comes in, the scientists looking at them usually know what to expect. They see a galaxy, they measure it, they move on. It is beautiful work, but it is also routine. On this particular day, though, the routine broke. A team led by a scientist named Peter van Dokkum at Yale University was studying a small, faint, faraway galaxy. Nothing about the galaxy itself was strange, but then someone noticed a thin, bright line sitting right next to it. A line that looked wrong. A line that should not have been there at all. At first, they thought it was a scratch on the image. Maybe a satellite trail, maybe a stray beam of light. That happens sometimes. But when they zoomed in, the line did not go away. It got clearer, sharper, longer, and the more they looked at it, the more their stomachs dropped. Because this line was not a smudge. It was not an accident. It was made of stars. Millions of them, stretched out in an almost perfectly straight line across the emptiness of space. And here's the part that is hard to wrap your head around. The line was nearly 200,000 light years long. Our entire Milky Way galaxy, with all its 200 billion stars, is only about 100,000 light years wide. So this thin, glowing strand was almost twice the length of our home galaxy, and it was not shaped like a galaxy at all. It was a line, straight, like someone had taken a ruler across the cosmos and drawn it there on purpose. The stars in that line were all young, all blue, all the same age. That should not happen naturally. Stars in a normal galaxy come in all ages and colors, mixed together like people in a big city. Old stars burning red, middle-aged stars burning yellow, hot new stars burning blue. But here, every single star was young and blue, as if they had all been born together in some sudden burst. Add them all up, and their combined weight was about 100 million times the mass of our sun. 100 million suns worth of newborn stars, packed into a thin needle of light stretching across the void. When Peter van Dokkum saw the image, he said the words that every astronomer knows are dangerous to say out loud. He said something like, "This had never been seen anywhere in the universe." And when a scientist tells you that, you should pay attention, because it means we have wandered off the map. So the question hit them like a punch. What in the entire cosmos could make a perfectly straight line of newborn stars almost twice the length of the Milky Way? What kind of force does that? What kind of object leaves a trail like that behind it? Nobody knew. And the not knowing is what makes this story so beautiful. The scientists sat down and did what scientists do. They started making guesses, educated guesses. The first guess was the safest one. Maybe it was just a very thin galaxy. Maybe they were looking at a normal galaxy from the side, edge on, like looking at a piece of paper from its thin edge instead of its flat face. From that angle, a round galaxy could look like a line. It was a boring answer, but it was possible, except it fell apart almost immediately. When they studied the light from those stars carefully, everything was wrong for a galaxy. A real galaxy would have old red stars and young blue stars mixed together. This line had only young ones, and at one end of the line, at the very tip, there was a glowing patch of superheated oxygen. Not the oxygen you breathe. Oxygen that had been blasted with so much energy that its electrons had been ripped away from it. That does not happen inside a peaceful galaxy. That happens in violence. So the thin galaxy idea died quickly. The next guess was more interesting. Some galaxies shoot out enormous jets of energy from their centers. These jets are like invisible rivers of radiation moving at nearly the speed of light. And when those jets slam into clouds of cold gas floating in space, they can compress that gas and trigger it to collapse into new stars. It has been seen before in other places. So maybe a nearby galaxy had shot out a jet, and the jet had smashed into a gas cloud and lit up millions of new stars along its path. Neat theory, but the numbers refuse to cooperate. Jets get wider the farther they travel from their source, like water from a garden hose spreading out as it flies. But this line was the opposite. It was fattest near the galaxy and thinnest at the far end. The action was also strongest at the tip, at the point farthest from the galaxy, not closest. Everything about it was backwards. If a jet did this, it should look like a cone, but this looked like a bullet. Something pointed, something moving, something with a front end. That is when the scientists started whispering the crazy idea to each other. What if this line was not created by a beam of energy? What if it was not the edge of a galaxy? What if it was the trail of something enormous flying through space, not sitting still, not shooting energy outward, but actually racing across the universe at speeds we can barely picture, leaving a wake behind it the way a speedboat leaves a foaming path through the ocean? And if that were true, only one object could possibly do this: a runaway supermassive black hole. Now, if you have never heard the phrase runaway black hole before, that is because until very recently it was mostly a thing on paper, a theory that lived in equations and computer simulations. Physicists suspected they should exist, but no one had ever caught one in the wild. The idea goes back to 1983, when a physicist named Michael Fitchett worked out something wild on paper. He asked, what really happens when two black holes crash into each other and merge? Everyone assumed it was smooth. Two black holes come together, they blend, and now you have one bigger black hole. Simple. But Fitchett showed the math was not simple at all. When two black holes spiral in and merge, they release a huge burst of gravitational waves, ripples in the fabric of space itself. And here is the strange part. Those ripples do not always leave equally in every direction. Sometimes they leave more strongly on one side than the other. When that happens, the newborn black hole gets a kick. Think of firing a gun. The bullet flies forward, and your shoulder gets shoved backwards. Same idea. The gravitational waves shoot out one way, and the merged black hole gets shoved the other way. And the math showed that if the two original black holes were spinning just right, that kick could be gigantic. Big enough to launch the new black hole out of its own galaxy at hundreds, even thousands of kilometers per second. A cosmic bullet fired from the barrel of a merger. For decades, that idea just sat there. Beautiful math, but no proof. Then Hubble's photograph landed on Peter van Dokkum's desk, and suddenly the theory had a face. If a supermassive black hole really was flying through space at insane speeds, this is exactly the kind of scar it might leave behind. Take a breath here for a second, because I want to say something. The fact that you and I are alive at a moment in history when we can actually see this, when we can look at a photograph of a black hole on the run, is genuinely one of the most incredible things about being human right now. If that sits with you, drop a comment below with just one word. The first word that comes to mind when you imagine that runaway black hole. I read them, and it means more than you think. All right, back to the story. To be sure of what they were seeing, the scientists needed sharper eyes. Hubble is amazing, but Hubble is also 30 years old. So they turned to the newest kid on the block, the James Webb Space Telescope. Webb is so sensitive it can see the faint glow of galaxies that formed just after the beginning of time. Pointing Webb at this line of stars was like taking off blurry glasses and putting on a perfect new pair. And when the new images came back, jaws dropped. Right at the front of the line, at the very tip where the whole thing seemed to be pointing, they saw a curved wall of glowing gas. A bow shock. If you have ever watched a boat cut through calm water, you have seen a bow shock. The water gets pushed up and out to the sides in a curved wave in front of the hull. Same thing when a jet plane goes faster than sound and rams through the air. Same thing when you drive through heavy rain and the drops burst outward against your windshield. Something solid moving fast enough through something softer will always leave that signature curved wave in front of it. Here in space, that softer something was thin gas and dust drifting between the stars, and something was slicing through it so hard and so fast that the gas was being crushed and heated to insane temperatures. The gas at the tip was superheated. It was compressed. It was moving faster than sound. Everything the scientists saw pointed to the same conclusion. Something enormous was tearing through the cosmos, and it was doing it right in front of their eyes in slow motion across millions of years. When they crunched the numbers, they got dizzy. The object at the front of that line had to have a mass of at least 10 million suns. Say that out loud. 10 million suns, squeezed into one point, flying through the void at about 1,000 kilometers per second. To put that in perspective, if it passed our solar system, it would cross the distance from the sun to Earth in about 40 hours. Faster than any spacecraft we have ever built. Faster than most people's imagination can handle. They gave it a name. They called it Runaway Black Hole 1, RBH1, and with that name, a rumor from 1983 finally became a real thing you could point at in the sky. Now here is where the story bends in a direction nobody expected, because black holes have a reputation. We think of them as the villains of the universe, cosmic vacuum cleaners. They swallow stars whole. They crush planets. Even light cannot escape them. They are the ultimate destroyers. So how in the world was this destroyer leaving behind a shining trail of millions of newborn stars? How was a black hole, of all things, acting like a gardener? The answer is one of the most beautiful ideas in modern astronomy. When RBH1 rams through space at 1,000 kilometers per second, it hits gas and dust in front of it and shoves it aside violently. That shove compresses the gas. The pressure sends shock waves outward and sideways. Just behind the moving black hole in its wake, that compressed gas starts to slow down, cool off, and pile up. Cool, dense gas is exactly the recipe stars need to be born. Little clumps form, gravity grabs the clumps and squeezes them tighter. The tighter they squeeze, the hotter their centers become. And when the center of a clump gets hot enough, nuclear fusion switches on. A star begins to shine. Now do that millions of times, one after another, all along the path where the black hole has already passed. And you get exactly what Hubble saw. A long, thin, glowing line of freshly lit stars, all born from the same violent passage. So the Great Destroyer, the thing we thought only ate and erased, is actually a kind of accidental creator. It punches through space so hard that it triggers new stars to be born in its shadow. A monster leaving a garden behind itself. I know that sounds almost poetic, but that is really what the data shows. Of course, scientists were not going to stop there. Now they had a new question. Where did this thing come from? A black hole flying that fast had to have been launched from somewhere. Something had to throw it. And because it left a straight, glowing trail behind it, they could just follow the trail backwards, like reading footprints in snow. So they followed. They traced the line of stars back the way it came. They followed the direction it was heading. And it led them to a very strange place. A distant object that looks almost exactly like the face of an owl. 2 big round eyes and a sharp beak in the middle. Astronomers had already given it a nickname before all this. Some called it the cosmic owl. Others called it the infinity galaxy. It sits somewhere around 7.5 to 9 billion light years away, which means the light we see from it left when Earth did not even exist yet. The cosmic owl looks like an owl because it is not actually one galaxy. It is 2 galaxies that ran into each other and merged. But here's the twist. Those 2 galaxies were not ordinary galaxies. They were both ring galaxies, and ring galaxies are almost impossibly rare. They only make up about 1/100 of 1% of all galaxies in the known universe. Only a few hundred are known to exist at all. Why are they so rare? Because to make one, another galaxy has to fly almost perfectly through the exact center of the first galaxy, punching a hole through it like a fist through a donut. Imagine trying to throw a dart from across a football field and hit the tiny center circle every time. Nearly impossible. And yet, the cosmic owl had 2 of them. 2 of the rarest kinds of galaxies had somehow slammed into each other at just the right angle to make an owl face in the sky. Statistically, that alone should be a headline for the year. Quick pause. If your mind is racing right now, welcome to the club. We are only halfway into this, and it gets better. If you are enjoying this, I have one small ask. Not a like, not a subscribe this time. Just, if you know one person, one specific person, who would love a story like this, share this video with them directly. Do not just post it. Send it to them. That personal share is what actually helps this channel keep making these deep dives. Now let us finish the story, because the ending is where it really hits. When the cosmic owl formed by those 2 ring galaxies crashing into each other, it was not a gentle event. It was chaos on a scale we cannot really picture. Millions of years of destruction and reshaping. Now, most galaxies have one supermassive black hole sitting at their center like a heart. When 2 galaxies merge, their 2 central black holes end up circling each other. They do not touch right away. They dance closer and closer, spiraling inward over enormous amounts of time. Eventually, they get so close that they merge into a single, much heavier black hole. And this is where the Fitchett math from 1983 becomes very real. When those 2 black holes finally slammed together at the center of the cosmic owl, the merger sent out gravitational waves in an uneven pattern. The waves went out stronger on one side than the other. That imbalance kicked the merged black hole with a mind-bending amount of force. It was fired out of the galaxy like a cannonball out of a cannon, and its speed, about 1,000 kilometers per second, which is exactly the speed of RBH1. Everything matched. The direction, the speed, the location, the age of the stars in the trail, the bow shock at the front, and the chemistry of the superheated gas. Every piece fell into place. RBH1 is the black hole that was thrown out of the cosmic owl during that ancient collision. And ever since, For millions of years, it has been sailing through the universe, drawing a line of newborn stars behind it. Take a moment and just sit with that. A single collision in a single strange place billions of years ago threw out a black hole that is still moving, still creating stars, still writing its own signature across the sky as we speak. If that does not make you feel small in the best possible way, I do not know what will. Now, here is where this discovery gets even bigger, because it does not just tell us about one weird object. It rewrites what we thought about the universe. For a long time, we assumed that supermassive black holes were permanent residents of their galaxies. Once a black hole formed in the middle of a galaxy, it stayed. It was the anchor, the center of gravity, the still point around which everything else moved. That was the rule. RBH1 just broke that rule, because if a black hole can be kicked out, then the whole picture of how galaxies live and grow needs to be redrawn. What happens to a galaxy after its central black hole is thrown away? Does the galaxy fall apart? Does it drift? Does it slowly stitch itself back together? Nobody knows for sure. These are questions astronomers had barely thought to ask, because nobody thought this could actually happen. Now it has, and the questions are pouring in faster than the answers. Once they had a real example to compare to, scientists started digging through old data with new eyes. They started asking, are there galaxies out there that look like they lost their black hole? Galaxies with something missing in the middle? And the answer, it turns out, is yes. There is a galaxy cluster called Able 2261. In the middle of it, there's a giant galaxy that, by every rule of astronomy, should have a monster black hole at its heart. Something with a mass somewhere between 3 billion and 100 billion suns. But when scientists look for that black hole, they cannot find it. The center is quiet, empty in the way you would not expect. It is like walking into a cathedral and finding no altar. The leading idea now is that the black hole was ejected, kicked out, just like RBH1. It might be out there somewhere in the surrounding space, drifting through the dark, trailing stars that we simply have not spotted yet. There's another suspect too, a galaxy in the catalog with a long, messy name, sitting about 228 million light years away. This galaxy has a strange feature. Its central black hole seems to be moving at a slightly different speed than the rest of the galaxy around it, as if it does not quite fit, as if it is sliding around inside its home. That is exactly the fingerprint you would expect from a black hole that has recently been kicked but has not fully escaped yet. It is still stuck, still wobbling, still on its way out. So within just a short time of confirming RBH1, astronomers had multiple candidates for other runaway black holes, not one weird outlier, a pattern. And here is the beautiful, strange consequence. If black holes really can be kicked out during mergers, and if galaxy mergers happen all across the universe, then the cosmos must be full of these cosmic runaways. Wandering black holes, drifting slowly across the void. Some of them creating star trails, some of them silent. Some of them eventually falling into new galaxies, merging again, and possibly being kicked out again. A cycle. Nomads bouncing across the universe over billions of years. When you picture the universe, most people picture something still, a calm sky of stars. But the truth is much wilder. The universe is a place where galaxies smash together, where black holes spiral and merge, where the fabric of space itself ripples like water. And now we know it is also a place where things as big as 10 million suns can be thrown across it like pebbles skipping across a pond. This is the part where I usually see people in the comments say something like, well, the universe does not care about us. And I get that. But look at what this discovery actually shows. The most feared object in the universe, the thing we thought only ate and destroyed, turns out to also be planting stars. And every star it lights up could someday form planets. And some of those planets could someday hold water. And some of that water could someday hold life, which means a black hole flying through the dark could, in a strange, indirect way, be the reason some future civilization gets to look up at their sky and wonder who else is out there. Destruction and creation on the same coin. The universe does not choose sides. It just makes both at once. And this is where I want to slide in one last small ask in a different way. If this video has made you feel even a little bit of that awe, just leave a single emoji in the comments. Anything. A star. A rocket. A little mind-blown emoji. That tiny signal tells the algorithm you actually enjoyed this, and it helps me keep making these long, careful stories instead of quick clickbait. Thank you for that. Truly. Now let us bring this home. The scientists studying RBH1 also asked another question that is genuinely unsettling. What about the stars that were already living in the path of this thing? Because remember, RBH1 is planting new stars behind it, but it is not tiptoeing forward. It is bulldozing through space. Anything unlucky enough to be in its lane gets shredded. Stars can be torn apart by tidal forces. Planets can be vaporized. Whole solar systems could be flung into chaos just by the black hole passing too close. So while its wake is a nursery, its front line is a war zone. It creates behind it, and it destroys in front of it. Both are happening at the same time. Nobody has figured out yet whether RBH1 has, on balance, added more life-friendly worlds to the universe or erased more. The math is not simple, but even asking the question changes how we see this object. It is not a hero, and it is not a monster. It is something older and stranger than either. It just is. Looking ahead, we are about to get much better at finding these runaway giants. The Euclid Space Telescope has already opened its eyes on the sky. The Nancy Grace Roman Space Telescope is on its way. Both are built to scan enormous patches of the universe with the kind of clarity Hubble gives us. That means faint, thin, easily overlooked features, like a delicate line of stars stretching behind a wandering black hole, are exactly the kind of thing they were designed to catch. On top of that, astronomers are training artificial intelligence to hunt through mountains of telescope data, looking for the specific fingerprints of a runaway. A bow shock here, a straight ribbon of blue stars there, a patch of superheated oxygen sitting alone in the dark. Computers can sift through billions of images in the time it takes a human to drink a cup of coffee. And every time they find a match, another runaway may be added to the list. If runaway black holes turn out to be common, and there are early signs that they might be, our textbooks will need serious rewrites. We will need to accept that galaxies are not stable homes with permanent hearts. They are more like busy cities where sometimes the mayor gets thrown out the window at 1,000 kilometers per second. We will need new models for how galaxies grow after a loss like that. New ideas for how black holes shape the universe not only from the inside, but from the outside as they wander between galaxies. And maybe most exciting of all, we will start to understand that the empty space between galaxies is not really empty. It is a highway. Something moves through it, something big. And that brings us all the way back to that single quiet Hubble image. A team of scientists looking at a small, faint galaxy, noticing a thin line of light next to it, almost dismissing it as a scratch, almost moving on. But not quite. They looked again. They asked another question. They allowed themselves to be surprised. And because of that, a piece of theoretical math from 1983 suddenly became a real object with a real name, flying through real space, painting real stars behind it. That is what science actually looks like. Not just charts and formulas. Sometimes it is a moment of stillness in front of a photograph, and someone whispering, "Wait, what is that?" So the next time someone tells you that space is empty, or that the universe is done surprising us, or that black holes are only destroyers, think of RBH1. Somewhere out there right now, at this very moment, a 10 million solar mass black hole is racing through the dark. Behind it, brand new stars are switching on one by one, like street lamps flickering to life as it passes. And ahead of it, an entire universe of gas and dust and possibility waits for its arrival. The question is not whether there are more like it. The question is how many, and what those trails will teach us about where we come from, what we're made of, and what could still be out there, waiting quietly in the dark for us to look up and finally notice. Keep looking up. Keep asking questions. Because if a single Hubble photo could show us this, imagine what the next one might reveal.